So if it's not big enough, if this piece of timber isn't strong enough to support a very large span opening, we need to create this more like a lintel. We could have a plate here. Let's just leave the plate there. And then we'll create another piece of timber. And we're going to rotate this one. And we'll make it even bigger. So let's stretch this all again. Shape stretch. And we'll stretch that another 50 millimeters. Now I would be inclined personally to do this not out of pine, but usually out of something like LVL, in which case I'd probably end up having it look something more like that. Try and choose the right fill. It's a bit too strong, but it's alright. Let's change the orientation. And this would be acting as a lintel. To support this, so we've got a header plate, sill plate. Of course, this can have a continuation of a stud underneath it, so we don't need much more than that. How deep do we want the niche to be? If we make it more than a wall thickness, so let's just finish this off by suggesting what's on the other side of the wall. So let's say we've just got plasterboard on the other side of the wall. And I'll make that 10 millimeters thick. So add another 4. How do we finish it? Do we want to block this wall out and make it much bigger, make it much deeper or wider? Probably not. That's probably not very practical. Do we need to insulate this wall? Hopefully not, because then we definitely will need to block it out or make it bigger. So how would we do this? We need to somehow create a structure that will allow us to make this the way that we want. Effectively, we need something stronger than plasterboard on the back of this. So this could be a piece of steel. So we can get pre-made boxes or boxes that are manufactured for this purpose, either standardized sizes or customized sized. Let's make that a lot thicker so you can see what I'm talking about. That effectively create a box for us. And the advantage of creating this out of stainless steel is it's moisture resistant, and then we can clad this or finish this as necessary. So we could sometimes, these can be created so they're actually post-fixed. They're fixed to the outside of the tile, and that's how they're left. But we definitely don't want that, and it's definitely more than likely going to leak. So we'd want that to be on the internal face. We'd want to waterproof over this surface. So this could be on the outside of the villa board, or it could be on the inside of the villa board. It doesn't really matter, particularly if we're going to be waterproofing it. Probably taking advantage of the sealed nature of the stainless steel edge would be smarter to put on the outside of the villa board. And then we could cut away the villa board. We want to waterproof around, so let's just trim all of these to make our life easy. And we'll move that to the back. I don't need to use waterproofing all the way around necessarily, but I will for now, just in case that was done with something other than stainless steel, which has a folded or a welded joint. When I get to the bottom, so of course I'll stretch it. Do the same at the top. Then we can mitre the joint. I'm going to turn the trace reference off just so it's easier to see at the moment. Let's bring this in a millimeter. Move, mirror a copy. There's too much stuff happening here. Let's reduce this down. Reduce this down. I'm just going to join everything and then we'll clean it up afterwards. And we want to mitre join these. Great, so here's another question. Can we have a stone top? We could have a stone ceiling. It depends on how far it's spanning. It depends on how we fix it. It would be harder to fix because it's harder to get the tile to glue to effectively the top of this. What would be another option? We could leave it as the stainless steel edge. We could finish it off with, if we weren't using a stainless steel box, we could finish off with Villa board or with a water resistant plasterboard. If that was in a shower recess, I wouldn't be so inclined to do that though. We could use timber. So there's a few different ways we could finish the top of it, and we definitely would normally tile the bottom. Move, mirror a copy. Let's do the whole lot of it. So there's a bit of drawing in this just because there's a lot of corners. And of course we're doing a vertical section, and we should also be doing a horizontal section as well, which would effectively look like this and then look like this. And so a niche has a lot of different details that we need to add into it. Offsetting all of these. Being internal corners, how should we finish it? Well, the stainless steel is not going to move anyway, so it could be a grouted joint, but we could also finish it with a silicon joint. And then if it was stone, I'd be inclined to finish it in the least visible way. Again, intersect, intersect, and we're getting close. There's a lot of corners. I could just mirror copy that to make it faster, but I probably want to do it the other way around. Do this a bit faster this time. Hope I got that angle correct. Great, so that's starting to look like the way we want it to. Turn that true line weight back on. This is our section in one direction, and then we'd need to create a section in terms of a jamb to finish that off. How was this created? This was created with a stainless steel tray, which creates the niche, gives us the waterproofing requirement. Most importantly, the waterproofing has to go over the top of the stainless steel tray, and we could do exactly the same thing. We could do this in a different way. I will show a variation of this where we're only using fiber cement sheeting to wrap all the way around. We just need to create some structure at the back of this in order to be able to support the fiber cement, because we can't use the plasterboard to be structural.